Day 693 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2946, matrix similarity after cyclic shifts. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n integer matrix mat and an integer k. The matrix rows are 0 indexed. The following process happens k times. Even index rows 0, 2, 4, etc. are cyclically shifted to the left. So it gives us a picture here. As you can see, we have 1, 2, 3, and as you can see, it shifts to the left. So meaning this 2 goes to the left, this 3 goes to the left, and this 1 goes in like a cycle or a circle and comes back over here. Boom, just like that. So it shifts cyclically, meaning at like a circle like this to the left. Boom. Odd index rows 1, 3, 5, etc are cyclically shifted to the right. So here we have 1, 2, 3. As you can see, we shift, this time we shifted to the right this way. Boom, cyclically, so it goes in a circle. So this 1 comes here, this 2 comes to this cell, and the 3 comes all the way back around to this first cell right here. Boom. It says, then return true if the final modified array or matrix after k steps is identical to the original matrix and false otherwise. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input is a matrix or mat equals a 2D array of integers, which is an n by n matrix. First row being 1, 2, 3, next row 4, 5, 6, last row 7, 8, 9, and k equals 4. Now before we continue, it's important to understand each one of these arrays inside of this 2D array represents a different row, right? So this right here is the top row of our input. Boom, 1, 2, 3. This right here is the middle row of our input, 4, 5, 6. And this right here is the bottom row of our input, 7, 8, 9. And remember, we're shifting the rows. So this would count as a row, this would count as a row, and this would count as a row. So this row, odd number rows get shifted to the left. So this gets shifted to the left, this gets shifted to the left. Excuse me, even number rows get shifted to the left, but it's still this gets shifted to the left and this gets shifted to the left. Odd number rows, which would be this right here, get shifted to the right, because remember, this is, and this would be row 0 and this would be row 2. That's what make them even rows. This would be row 1 in the 0 indexed array. So this what makes it an odd row. And so this odd row gets shifted to the right, the rest gets shifted to the left. So let's go through it, right? Let's look at, see what it does, see what happens. We have to shift 4 times because k equals 4. So this first is the input. This grid right here is our input grid. This matches this right here. Boom. After the first shift, right, so this goes to the left. So that means the 2 goes here, the 3 goes here, boom, and the 1 loops around it here. Boom. So we did that. Then this row goes to the right. So this 5 goes here. The 4 goes here, and then the 6 wraps around, boom, here, and then this bottom row goes to the left again. So once again, the 9 moves here, the 8 moves here, sorry y'all, and the 7 moves around like this, boom. So that was the first shift, but now we have to do 3 more shifts because k equals 4. So then we do it again. Once again, we keep shifting the top row to the left one more time. As you can see, 3 goes from here to from this cell to this cell, boom, 2 loops around, so the 2 is here, and the 1 goes from this cell to the middle cell. Same here, except this time we go to the right. So 4 is going to loop, yeah, we're going this way. This time we're going this way. So the 6 will go here, the 4 will go here, and then we loop around, boom, and then the 5 ends up over here. Sorry, we're looking at this one. So sorry y'all. We're looking at this one right here. So the 5, we are going this way, right? We're going this way. So the 5 loops around to here, boom. The 6 moves here, and then the 4 will move here, boom, just like that. Then this row, we're going back to the left. Both sides, because we're starting here. That's why I'm moving too fast. So this 9 will move to this cell right here. This 8 will loop around to here, and then this 7 will move to this cell right here. Boom. Now we're at this cell. We're looking here. We still have some more shifts. This time, once again, this is going to shift to the left. So once again, the 1 goes here. The 2 goes to this cell right here, and then the 3 wraps around. Boom. Just like that. And then from here to here, we're going to the right. So this 6 goes to the right. This 5 goes to the right. Boom. And then this 4 will wrap around. Boom. That's why the 4 is over here. Then down here, we go to the left. Once again, the 7 goes to the left. The 8 goes to the left. The 9 loops around. Boom. And that's how we end up with this array. Boom. Now we have one more shift. So once again, top row goes to the left. So the 2 will go here. 3 will go here. Boom. 1 wraps around it here. Boom. This goes to the right. So then but we're looking here. So it goes, the 6 wraps around to the front. Boom. Then the 5 goes from the middle cell to the right cell. And the 4 goes from the left cell to the middle cell. Boom. Then down here, we are going to the left again. So 7 is going to loop around. Boom. We're going to move 9 to this middle cell right here. And we're going to move 8 to this bottom left cell right here. And this would be the final, sorry, can't copy and paste, but this would be our final grid after all the shifts. Now, since this grid does not match this grid, we could return false. Boom. Because that means the final modified matrix after k steps is not identical to the matrix, right? Because this is not identical to this, so we return false. So let's take a look at example 2 where they would be identical. So in example 2, our input mat equals a matrix or a 2D array of integers. Top row being 1, 2, 1, 2, middle row being 5, 5, 5, 5, and the bottom row being 6, 3, 6, 3. K equals 2, so we only need 2 shifts. Boom. So after the first shift, once again, we just shift, so the top will go to the left, I believe. Yes, so top goes to the left. We move everything to the left and bring this 1 back around. The top row will look like this. Middle row is all 5, so nothing's going to really change. It will still be all 5s. And then the bottom row, we're going to shift to the left. So this 6 is going to come around here, and then this 3, 6, we're going to push it all to the left that way. Boom, and we'll be left with it looking like this. Then from here, we still have one more shift. So once we shift again, this 2 will wrap around to here. Boom, and we'll shift these 3 to the left. It'll look like this. 5s, once again, we'll just shift these all to the right, but it will still look the same. And then we'll take this row and we'll shift it to the left again. So this 3 is going to wrap around to the end, and this 6, 3, 6 is just going to move down a cell each. So it looks like this in the end. Boom, and in the end, this input cell matches this this final matrix after k shifts, so we can return true. And just in case that didn't make sense, let's take a look at example 3. Example 3 is a little simpler because it's similar to this row where all of the elements are the same. So it's not going to matter how many shifts we do. So in example 3, our input mat equals a 2D array of integers or n by n matrix. Top row being 2, 2, bottom row being 2, 2, k equals 3. Output is true. Explanation says, as all the values are equal in the matrix, even after performing cyclic shifts, the matrix will remain the same. Similar to this middle row, no matter how we shift it, since all the elements are the same, no matter how we shift it, the end matrix will look like the input matrix. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. Now, first thing we want to do is we're going to get the number of rows. So we're going to say let m equal mat.count. Boom. Then we need the number of columns. So we're going to say let n equal mat square bracket 0 dot count. Boom. Now we're going to normalize k to avoid unnecessary full rotations, and shifting by n results in the same row. So we're going to take modulo. So we're going to say let k equal k mod n. Boom. Now we need to iterate through each row. So we'll say for I n 0 dot dot less than m. We'll open up the brackets, and then we're going to iterate through each column in the row. So we're going to say for j in 0 dot dot less than n, we're going to open up the brackets, and we're going to compare the current element with the element that would appear after shifting the row to the right by k, by saying j plus k mod n is going to handle circular wrapping. So we'll say if mat square bracket I square bracket j does not equal mat square bracket I square bracket j plus k, come outside of that, oh sorry, put the j plus k in parentheses, but still inside the square brackets, then come outside those parentheses, we're going to mod n, still inside the brackets, come outside the square brackets, open up some regular brackets, and we can say return false. Otherwise, if all elements match their shifted positions, we can return true by coming right here, and we can just say return true, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. Boom, y'all, and look at that. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.